What is a set? I'll try and keep this short and to the point. So, the classic book on this is Halmas's Naive Set Theory. And he says basically a pack of wolves, a bunch of grapes, or a flock of pigeons can all be viewed as a set. Sometimes he says collection, sometimes he calls it a class. Another example of a set, for example, is a bag of groceries. The groceries are the set of objects. So, like the milk, the butter, those are all parts of the set. You can have uh, a line that's a set of points. All the lines in the plane is a set of sets because the lines are sets of points, and the collection of lines, that's another set. You can use the little e epsilon to say that something's an element of a set. Like if your collection is that bag of groceries, your little x there might be the butter or the milk. Those would be elements of your set. So, Halmas's book is the classic on the topic. This book, Abstract Algebra, I'll show you. It is Derek Robinson's recent book, the third edition. And he starts with sets. One of the reasons I'm showing you this, show you it's pretty standardized. He says by a set, we will mean any well-defined collection of objects, which are called elements of the set. So it has to be well-defined. You have to, like the rule has to be clear for generating the elements, or what the objects or elements are in the set needs to be clear, needs to be defined. Well-defined needs to be taken seriously. A collection that is not a set, right, if it's not well-defined, that's going to be called a proper class. There's that notation again, where the little a is an element of the set A. Like if the set A is A, B, C, D, then you can have B here or C or D there for elements. It's a common way of designating a set instead of listing the elements is to say the element, the vertical line is such that the element has some particular property P, like the groceries in a bag. So the property is everything that's in the bag. And those would define the set. And then we could write it out here in the brackets. The brackets is like the bag. Um, Actually, so let me just show you a few things on sets. Um, this is a classic book, Rudin's Real and Complex Analysis. I got this way back in the day at Book Scientific on 18 East 16th Street. And in this book here, he defines set at towards the beginning. So if you can see it, the page, if it focuses, you see set theoretic. So I'm going to read that a little bit. So some sets can be described by listing their members. Thus, x1 dot 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 xn is the set whose members are x1 through xn. Bracket x is a set whose only member is x. More often, sets are described by properties. We write bracket x colon p, specifying the element with the property p. If A is contained in B and B is contained in A, then they're equal. A set is contained in another set if every element in it is an element of the other set. So you see, it's pretty common to define a set. See if I can get the full thing here for you. So let's say A is 1, 2, 3. By the way, if I wrote 1, 2, 3, 1 in there, it would still be just 1, 2, 3. You can't, repeating elements doesn't mean anything. Also, if I wrote 3, 2, 1, it's the same thing. The order doesn't matter in a set. So those are two things you should know. Let's let B be 1, 2. And C be 1, 4. Okay, so that's very simple. You can see that B is a subset of A. Every element of B, 1 is an element of B, 1 is an element of A. If every element in here is an element in here, then it's a subset. C is not a subset of A. Because 4 is in C, but 4 is not in A. The empty, so one more item here. I apologize. I just thought of one more thing and then I'll end this video. I'm trying to keep it short and to the point. So the empty set is a subset of every set. And every set is a subset of itself. Because every element of this is an element of this. So basically, Rudin used this notation to list the elements of a set and elements in it. This is a set with the singleton X. And the common notation is X that has some property P. I'm out of time. So basically a set is a collection of items listed usually between curly braces, sometimes with a rule. Sorry. Like, for example, you might say the set of all X such that X lives in New York City. So this would be, say, all the people that live in New York City. That would be the rule for determining all the elements in New York. There's more formal notation. This is a little informal, actually. The double dot is the such that. Now, if I designated Atlanta, and that would be another set, Brooklyn is a borough of New York City, so Brooklyn would be a subset of this. All the elements in Brooklyn, all the people in Brooklyn would live in New York, for example. The United States, all the cities in the United States, that collection is a collection of sets. The sets being the cities that have people in them. That would be a set of sets. So, and you can also, the United States, have the states, New York and Georgia, as subsets of that. And those states have the cities, like in New York, the Buffalo, Albany, Syracuse, New York City. Those are all subsets of the state of New York. So you can have the United States contain the sets, which are the states, which contain sets themselves, which are cities and towns or whatever you want to designate them as rules. And that is an introduction, a basic understanding of what a set is. If you have any questions, please post it below the video. I would say that I use Rudin's book and the algebra books to show you that this is somewhat standardized, and the naive set theory book to show you the classic on set theory, of which this is the very beginning of. Thank you. So a set is just basically a collection of objects or elements.